A shaking blower will may be out of balance, but vibration alone is not proof.
Look for one strong frequency clue, confirm it in 3 directions, inspect 5 physical conditions, and avoid 4 shortcuts that can make the wheel less safe.
Imbalance means the center of mass does not sit on the rotation axis.
Once per revolution, that offset produces a rotating force. The force grows with offset mass, eccentricity, and the square of speed, so a small defect can become dramatic at full RPM. Before inspection, stop the blower, isolate every energy source, lock and tag, release stored energy, and wait for the wheel to stop completely.
Verify zero energy before entering the guarded area. Replace every guard before restarting. Now confirm the hypothesis.
Record vibration at the bearings in horizontal, vertical, and axial directions, along with fan speed, load, and operating point. A strong peak near fan speed with repeatable phase supports imbalance. It does not prove the cause by itself.
The first common cause is uneven buildup.
Dust, grease, or process material shifts the mass center. Photograph the wheel before cleaning, remove deposits uniformly, and inspect the newly exposed surfaces for wear, erosion, cracks, or loose hardware.
The second cause is a missing correction weight.
Do not guess the replacement mass or copy the weight position from another wheel.
Inspect every correction point and preserve traceability.
The wheel, hub, and mounted configuration that will actually run must be evaluated together. The third cause is damage, a bent hub, distorted wheel, loose attachment, cracked weld, or rubbing event.
Check runout and mounting only in the safely isolated state.
A structurally unsafe wheel is a replacement or qualified repair decision, not a balancing experiment.
Next, rule out the lookalikes. Looseness often adds harmonics or changing phase. Bearing faults can produce non-synchronous or higher frequency energy. Misalignment and a bent shaft have different directional clues.
Resonance often peaks sharply within a narrow speed band.
Use the complete pattern.
The correction sequence is simple to remember. Record the baseline, clean uniformly, inspect the wheel and hub, verify mounting, balance the complete running assembly with the proper procedure, then repeat the same test.
Correction plane, mass, angle, and acceptance limit are model specific.
For shortcuts are never a diagnosis. Attaching a weight by feel, copying another wheel, grinding or drilling without an approved method, and trying to balance a cracked part.
Each removes evidence and can create a projectile, a new stress concentration, or a second imbalance. This guarded longwall station shows controlled rotation, protection, and measured correction in a production setting.
The screen values are not a universal field limit. Your result must come from the actual assembly, specified speed, mounting, and applicable acceptance criteria. So the complete path is, make the machine safe, measure 3 directions, confirm the running speed clue, clean and inspect, rule out lookalikes, correct the assembly, and repeat the same condition test. For a balance review, send wheel photos, RPM, mounting, vibration by direction, phase if available, operating point, and maintenance history.